Today's lesson is the Fundamental Theorem of Algebra 2. I want to kind of direct your attention to the theorem, and I'm going to summarize. It says where it says take note, key concept. What it's saying is that if the degree is greater than or equal to 1, then the polynomial has exactly n amount of roots. And I'm going to give you an example of that right now. So if I look at example A, and you see how we raise to the fourth power, that means there are going to be 4 roots. Now, every polynomial, if you see that first bullet, every polynomial has at least one complex zero. Okay, so you will have a complex number. You have at least one of them. Every polynomial of degree n has n linear factors. That's another key point. So for example, 4, there's going to be 4 linear factors. So let's look at example A. It says finding all the zeros of a polynomial function. And they're giving you the graph for the reason that you can see the actual 2 solutions, which are x equal -3, and this is x equal 3. So we have these roots, x plus 3 and x minus 3. So now what we're going to do is we're going to do synthetic division twice, and we're going to use -3, and we're going to use 3, and then we're going to come up with the rest of the zeros for this polynomial. So it's basically the same thing that you've been doing on the last lesson. So as I said before, we're going to go ahead and do the synthetic division twice. So once it's going to be -3, and we have 1, 1, -7, -9, -18. 1, -3 times 1 is -3. 1 plus -3 is -2. -3 times -2 is 6. -7 plus 6 is -1. -3 times -3 is 3. -9 plus 3 gives you -6. -3 times -6 gives you 18. So that's your remainder. So now the new polynomial is x to the third power minus 2x. So we have x to the third power minus 2x squared minus 1x minus 6. So we're going to go ahead and do it again, but we're going to use 3. So we have 1, -2, -1, -6. Bring this down, so you have 1. 3 times 1 is 3. -2 plus 3 is 1. 3 times 1 is 3. -1 plus 3 is 2. 3 times 2 is 6. So it's 0. So your new polynomial is x squared plus x plus 2. And we're going to solve this for 0. You notice that these two answers are going to be either they're going to be not irrational, but they're going to be complex numbers. There's actually going to be 2 complex numbers. So we're going to go ahead and find the 2 roots. So we have a equals 1, b equals 1, and c equals 2. So let's go ahead and use the quadratic formula. So we have x equals -1 plus or minus square root 1 minus, and we have 4 times a, which is 1, so it's 4 times 1, times c, which is 8, divided by 2 times 1, which is 2. So we have x equals -1 plus or minus square root of -7 over 2, and there is our complex number. So we have x equals -1 plus the square root of 7i. Remember that I is the square root of -1 divided by 2. And then the other complex number is its twin, -1 minus square root of 7i over 2. Remember, this is a complex conjugate, complex conjugate. So we have x plus 3, x minus 3, and then we have x plus or minus 1, negative 1, no, 1, square root of 7i over 2. So there are 4 roots and 4 answers. So we're going to go ahead and find the 3 roots, or the 3 linear factors. How do I know it's 3? Because it's raised to the power 3. So we're going to start by finding the possible factors. We have plus or minus 3, plus or minus 1, divided by plus or minus 1. So it's just plus or minus 3, plus or minus 1. So let's go ahead and try 1. We're going to use synthetic division to see if 1 is a solution. So we have 1, negative 3, 1, negative 3. Bring down 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. 1 minus 2 is negative 1. 1 times negative 1 is negative 1, so it's negative 4, so that's not it. Let's go ahead and try negative 1. So we have 1, negative 3, 3, no, negative 3, 1, negative 3, 1, negative 1 times 1 is negative 1. Negative 3 plus negative 1 is negative 4. Negative 1 times negative 4 is 4. 1 plus 4 is 5. And then negative 1 times 5 is negative 5, so it's negative 8. So that's not going to be it. So let's try 3. I'll use a different color. We have 3. We have 1, negative 3, 1, negative 3, 1, negative 3, 1, negative 3. So you have 1. 3 times 1 is 3, 0. 3 times 0 is 0. So you have 1. 3 times 1 is 3. Negative 3 plus 3 is 0. So that is our first answer. X equals 3. And what do we have left? We have, since it was raised to the 3rd power, it's going to be x squared. The 0x is ignored. Plus 1 equals 0. So we have x squared equals negative 1. Square root of both sides. So x equals plus or minus I. So our answers are x equal 3, x equal I, x equals negative I, but that's not what they want. They want the linear factors. So let me write down the factors. So we have x minus 3. So you have to move the 3 to the left. So it's x minus 3, x minus I, and x plus I. 2 of them are complex numbers, and they're also called complex conjugates. And then the other one is x minus 3.